My name is Muhammad Alif Muhammad Zaman, nombor matrix 14 DKM 19F1019. My part in presentation, equilibrium of force is 1. Objective to present force acting a practical place using graphical method. Part 2. Theory and introduction. The design of all typing of structure is based on the effect of they on which the force acting on them and with other the structure is moving. Normally, in structure design there is not motion and the bodies are said to be in static equilibrium. Newton's first law of motion say an object at rest, that to say at rest an object in motion with the same speed and in the same direction. Unleashed except by an imbalance or expansive force. A system of force in equilibrium satisfies two principles. 1. The resultant of the force must be 0. 2. The moment of the force about any point must be 0. The usually mathematical way of writing this for a three-dimensional system is with six conditions: fx, fy, fz0, mx, my, mz0. Graphical method. If a system of force in one place acting on the body is in equilibrium, that the vector diagram is a closed polygon. In case where there are three concurrent forces on the axis, the diagram folds in a triangle. Mathematical method. The most common two-dimensional resolution of a force vector is into recalculate component. The fx and fy are vector component of f in the x and y direction.
Assalamualaikum dan selamat sejahtera. Equipment and apparatus. The equipment that we use on the lab are 6 equipment. First one is force board. Force board, the function of force board is helps a student visualize how force act and give them a practice with vector addition as force is a vector. Second one is pulley. A pulley is a wheel on an axle or shaft that is designed to support movement and change of direction of a towed cable or belt. Third one is hanger. Function of hanger is measuring weight and used in hanging different objects. Fourth, slotted weight. Function of slotted weight. The slotted mass or weight hanger combination allows a student to quickly create any desired amount of mass to use in experiment involving force, acceleration, and mass. The fifth one is string. String is a thin piece of rope or twine wise is used to tie, bind or hang other objects. String can be made from a variety of fibers. The last one is protector. Function of protector are to measure an instrument, typically made of transparent plastic or metal for measuring angles. Procedure. First step are suspend the hanger on the string as shown. Second step are place some weight on the hanger. The last one step is record the angle and weight on each string, include the weight of the hanger. Assumptions. First, the pulley are frictionless. Second, the strings are very thin so that the directions can be marked out accurately. Third, the mass of the string is negligible. Thank you.
Hi, Assalamualaikum. So my part, I will tell you about result. So this is the calculation data for use of 40 gram and we use 50 gram and 100 gram. So the result we got for the 50 gram, force 1 and force 2 we use the same weight. The weight is 0.392 Newton, but a different angle, which is 48 degrees and 45 degrees. For the result, x axis for we got 0.2623 Newton, and for y axis we got 0.2913 Newton. For the second is 45 degree. We got for x axis 0.2772, and y axis we got 0.2772. For the third force, we use 0.49 Newton, which is angle is 19 degree. So the result for x angle we got 0 Newton, and the y axis we got 0.49 Newton. For we plus for the all x axis we got 0.5395 Newton, and for the y axis we got 1.0585 Newton. That result is about 50 gram. For the table 2, which is 100 gram, like also we use the same weight for the first force 1 and force 2, which is a 0.588 Newton, but the different angle, which is 60 degree and 55. For the result, for angle 60 we got 0.2943 for x axis, and y axis we got 0.5097 Newton. For the second result, which is 0.588 Newton, and an angle we 55 degrees, and the result is x axis 0.3375 Newton, and the y axis we got 0.4821 Newton. For the force 3, we use 0.98 Newton, and the angle is 90. For the result for x axis is 0 Newton, and the y axis we got 0.98 Newton. For we got for x axis we plus all of the result, we got 0.6318 Newton, and for the lastly is y axis we got 1.9718 Newton. For the formula we use for calculation is for x axis we use cos, and for the y axis we use sin. So next,
For the discussion is, if an object is at rest and is in a state of equilibrium, then we will say that the object is at static equilibrium. Static means stationary or at rest. A common physics lab is to hang an object by two or more strings and to measure the force that are exerted at angles upon the object to support its weight. The state of the object is analyzed in terms of the force acting upon the object. The object is a point on a string upon which three forces were acting. See diagram at right. If the object is at equilibrium, then the net force acting upon the object should be zero. Thus, if all the forces are added together as vectors, then the resultant force, the vector sum, should be zero. Another way of determining the net force, vector sum of all the force, involves using the trigonometric function to resolve each force into its horizontal and vertical components. Once the components are known, they can be compared to see if the vertical force are balanced and if the horizontal force are balanced. What we get in this lab work are the difference between the theoretical and experiment values. What we can conclude is there got slightly different value between the theoretical and experiment values. The why got the different was got some error. For the conclusion is in conclusion, equilibrium is the state of an object in which all the forces acting upon it are balanced. In such case, the net force is zero. Knowing the force acting upon an object, trigonometric functions can be utilized to determine the horizontal and vertical components of each force. If at equilibrium, then all the vertical components must balance and all the horizontal components must balance. Also, we know the calculation equilibrium of force using a resolution of force method. Lastly, we got experience and now how to use the equipment, also the function of the equipment.